In this video, we'll go through 3 ways to handle camera movement in Unity. Here we have a simple 2D scene with a player that can move and a camera looking at the player. Now for the camera to follow the player, we're going to drag and drop the camera on the player. By doing this, we are setting the camera to be a child of the player. So now anything that happens to the parent, being the player, will also affect the camera. This is by far the easiest way to handle camera movement in Unity. But what if you don't want the camera to always be glued to the player? What if you want the player to have some free movement without the camera tagging along? One way to achieve that is by setting boundaries. So essentially you're gonna say if the player is going outside the set boundaries, start following it. To do that, we're gonna make a new script called camera follow, and inside our code editor, we're gonna need a public float called bound right and another one called bound left, and a public transform named player. Now inside the late update, we're gonna check if the player is going outside the bounds by accessing the player's transform component and start following it. Late update is a predefined method by Unity that gets called on each frame after the update function. So if player.position.x is greater than camera's x position plus bound right, set the camera's position to a new vector 3, which for the x-axis has the player's x position minus bound right, and for the other two has the same values as the camera. Else, if the player's x position is less than the camera's x position plus bound left, set the camera's position to a new vector 3 that has player.position.x minus bound left for its x value and the same values as the camera's position for the other two. Back to Unity, attach the script to the camera and drag and drop the player game object on the player variable. Now for the boundaries, you can select the player and start moving it around to get an idea of where you want to set the boundaries. I like the bound right to be at 1 and bound left at minus 4.5. Start the game, and as you can see, we have a perfect platformer type camera movement system set up. Of course, you can use the same approach when the player jumps, but this type of camera movement system doesn't usually get used in 3D projects. So what if you're working on a 3D project and the previous two methods don't fit your game? Or what if you want your camera to be a bit more dynamic and not cling to the player? To cover that, I'm going to switch to a game I worked on a while back. So here we have a 3D scene and a player with a movement script attached to it. Of course there is a lot more going on in this game that we're not going to go through in this video. Now let's create a new C# script, and before opening it, let's acknowledge the fact that there is a lot of work that needs to be done to make this 5-minute video. So smash the like button and subscribe to support the channel. Also, if there is any specific topic you want me to cover, go ahead and leave a comment and I'll look into it. So the way we're gonna do this is that we're gonna get our desired offset to our player and then use vector3.lerp to smoothly get back to that relative position anytime the player moves. So of course we need a public transform called player to get a reference to the player's position, a vector3 named offset, and a public float called t for the lerp method. Now in the awake function, we're gonna set the offset to the camera's position minus the player's position. Quick reminder, awake is a method provided by Unity that is the first to execute when starting your game. So instead of figuring the offset out ourselves, we're setting the camera on a good relative position to the player, and then when we start the game, we're going to command the computer to calculate the offset for us. Now in the fixed update, which by default gets called 50 times per second, we'll set the position of the camera to vector3.lerp, and for the first argument, we'll pass in transform.position, the camera's position, and for the second one, the player's position plus offset, and for the third one, we'll put in our t variable. Keep in mind the value of the t has to be between 0 and 1, because the way the lerp method works is that it takes two vector3 variables, being our positions, and based on the value of the t, it's going to return a new vector3, considering 0 to be the first position and 1 the second. So if you set the t to 0.1, the camera is going to get 10% closer to the desired position on each attempt. Now going back to Unity, let's attach the script to the camera and drag and drop the player on the player variable. Give a value to the t, and that's it. Start the game and you should have a dynamic camera following the player. If you want an in-depth tutorial on how lerping works, watch this video next and stay a golden developer.